Hi again, this is a bonus solve video. We released a special puzzle pack on February 29th for Leap Day, and this includes puzzles by the Gas team, but also by the Gap team, genuinely approachable pencil puzzles. They post a daily pencil puzzle on the Discord. And we've swapped puzzles before. Typically we do a swap about twice a year, once in February and once in August. And this year, because of the Leap Day, and because we didn't really have our act together otherwise, I suggested that we just put a pack together and release all of them on Leap Day as a special event. And so I'm doing the solves for the Sudoku at least. I don't know if we'll do a video for the pencil puzzles. We might. Let us know if you would be interested in that. But I'm going to tackle the Sudoku. There are 7 of them. One of them should not be in this pack. Bill posted a puzzle that was intended for his Patreon originally. He was just sharing it with the team, but he posted it in the middle of other people sharing puzzles for the pack, and I did not realize that it wasn't for the pack. And when I test solved it, I kind of sped through it and did a little bypass of the intended step, and also didn't notice that even my bypass was way too much for gas, just because of what was on my mind at the time. Anyway, so Bill made a different version for Patreon. You get the unintended bonus version, and I will try to demonstrate the intended path and also how I bypassed it. The first 5 puzzles in the pack are all by the setters for Gap, and this first one is by Walker. It's an Aeros Soku. Most of them are also 6x6. There's one exception, which we will get to eventually. But in 6x6 Sudoku, we're placing the digits 1 to 6 in each row and column, and in each 2x3 box. I have said 3x3 too many times. In each 2x3 box, typically, we'll get to one puzzle where that doesn't apply. But this is also an arrow, so the digits along an arrow must sum to the circle total. Digits can repeat as long as it's allowed by normal Sudoku. So we're going to start with this arrow. There's a 4 already on it, and we have 2 more digits that we need to place. The lowest we could place is 2 1s, and that already totals 6. So in fact, that is what we have. We're left with 3 5 in the column. This arrow, there's 2 ways you could look at this. There's already a 2 on it. The lowest these could be, ignoring everything else in the puzzle, is 1 2. And that would be 5. But we know this can't be 5 because there's a 5. So this has to be 6. But also, neither of these can be 2, because there's a 2 here. So actually the lowest is 1 3, and this is 6. The 1 3 gives us 5 3 and 1 3. The 2 has to go here, so the 4 here. These are 4 6. 6 and 4. These are 1 and 5 in some order, which we're going to resolve in just a second. This arrow, the lowest we can have is 1 2 3, because these all see each other. We can't have any repeats on this arrow. And that sums to 6. So that has to be the makeup of that arrow. This is not 1, this is not 2. We need 3 5 here. And now that we've got the arrows, we can kind of speed this puzzle. 5 here, 3 4, 1, 6 5, 2 3 and 6. So that's our 6 3 2 3 1 and 2. And that is how you solve this Aeros Soku by Walker. The next one is a Vault Sudoku. I think we've done one of these for regular gas before, but it's been a while if we have. And I don't remember for sure if we have. It might have been in the, or I might just be thinking of something else. This one might take a little longer just because the rule is unfamiliar, but it is really genuinely approachable. This is by Lavaloid, and we have normal Sudoku rules for 6x6. We also have cages, and these are not killer cages, so we can repeat digits. That is allowed in the rules. What is not allowed is for any of the orthogonally adjacent cells to this vault, to this cage. None of these digits can be in the cage, or whatever is in these two cells cannot appear in these cells. So those are the rules. And we'll start with the vaults that already have 2 digits in them, and specifically we'll look at the digit that is outside of the box that the other two cells are in. This 2 already can appear here, but these 2 cells are also adjacent to the vault, so they can't. So the only place for 2 in the box is here. Same goes for 3 down here. 3 can't appear here. These are next to the vault. So this is 1 and 4 in this box can't appear here. So these are 1, 4 in some order. But the vault actually resolves them, because there's a 1 in this vault, so this can't be 1. There's a 4 in this vault, so this can't be 1. So these are 5, 6. Now, what can this be? It can't be 1, 2, 3, but it also can't be 4, because now there's a 4 next to the vault. So this is also 5 or 6. And we have a 3 here, so this is 6, 5 in this order, because it's 5. This is also going to be 5 or 6. It can't be 1 because of that. But actually, we now know which order they're in. This 5 is next to this vault, so this is 6, 5, 5, 6. The 6 is next. So this one's a 6. This is 1 and 2. And we've done the left half. And now we're just going to fill in the possibilities here. We can do the same thing with the 5. 5 can't go in these cells, but it has to go here. But otherwise, we're going to end up with a bunch of pencil marks that it's not immediately obvious how to resolve. We can eliminate the 1 here, because there's a 1 adjacent to the vault. So 1 can't go in this cell. We can't say the same about 6. 6 is in the adjacent vault, but it is not adjacent to this vault. And this cell is not adjacent to this vault. So there may be more than one way to look at this. Actually, 5. But what I did when I solved it is look at this 2, 4 pair. So both of these are adjacent to this vault. Wherever the 2 is, it's next to the vault. So we can't have a 2 inside the vault. And with that little step, the whole puzzle collapses. So this is 2, this is 4, this is 2. Now, 2, 3, 4, we have 2 and 4 in column, so this is 3, this is 4, this is 2, this is 2. We have a 3 next to this vault, so this is now 6. This can't be 3, so it is 1, 6, 1. This is 3, 1, 3. Finally, 4, 6. And that's the solution to vault Sudoku. The next one is an irregular little killer by Menderbug. So this time we don't have 2x3 regions, we have irregular regions. So 1 to 6 in each row, column, and outline region, which could be any shape. So 1 to 6 appear in this shape, and in this shape, So little killer, we have clues outside the grid, and they give the sum of the digits along the diagonal that they're pointed at. So these 6 cells sum to 20, these 5 cells sum to 20. And we can immediately place 1 digit here. The 2 is pointing at 1 cell, so it has to be 2. It's not super common to have a 1 cell little killer clue, just aesthetically, but we're going for a theme here. Menderbug put in 2024, 229. Let's see. So, nice little touch. And now we're going to look at the big clue. So 29 in 5 cells. In a 6x6, the most we can put in one cell is 6. So the most we can put in 5 cells is 30, which is close to 29. But we actually can't put 6 in all the cells because these two cells are in the same region. They're both in this region. So the highest they can be together is a 5-6 pair. That's 11. And then 3 6s is 29. So that's what we have to do. We try and go any lower with any of these cells, we're not going to be able to get 29. Now the 24 can no longer have a 6 on it. So this sees a 6, this sees a 6, this sees a 6, this sees a 6. And this is the hard step in this puzzle. This also sees a 6. We just don't know where it is. One of these is a 6. But wherever the 6 is, it sees this cell. So this cannot be a 6. It also can't be a 5 for the same reason. So the highest this can be is 4. And to get to 24 without using 6, we have to have all 5s. And now 5 is going to resolve the order of our 6, 5. 6 in this column can only go here, the last 6 goes here, and we need a 5. And we'll come back to the 20 toward the end. That's going to resolve our last digits, but for now we can do some, well, I was going to say regular Sudoku. We're going to do some irregular Sudoku. We have a 2 here. The only place it can go in this region is here. The only place in this region is here. The only place in this region is here. The only place, it's already here. What have we got left? The only place in this region is here. And now we need to push it off. 4 can't go in these cells, so this is a 4. In fact, I'll pencil mark ones. These aren't 4, so this is 4. These aren't 4, so this is 4. This isn't 4, so this is 4. And our last 4 is here. Now we have a bunch of 1, 3 pairs everywhere, and they are resolved by this. So we have 2 plus 4 is 6, plus 2 is 8, plus 6 is 14. To get to 20, we need 6 in these two cells. They're both 1 here. And now 1, 3, 1, 3, 1, 3, 1, and 1. And that is the solution. This is Sum or Product Sudoku by Freddie Hand. This one is a little different because of the ambiguous clues. We do have normal Sudoku rules, 1, 2, 6 in each row, column, and 2 by 3. The circles give us either the sum or the product of the 2 digits. And some of these could be both. So this 3, for example, could be 1 plus 2, like in a 2-cell filler cage. But it could also be 1 times 3. So those are both possible. Some of them only have 1 possibility. So these 2's, the only way we can do that is 1 times 2. We can't make a sum of 2 in 2 cells that see each other. These are too big to be sums. You can't make 24 in 2 cells in 6 by 6. So this has to be 4 times 6, and this has to be 5 times 4 in that order because the 4s are 2. Now 6 in this box has to go here. So these are 1, 2, 3. This is 1, 2, 3. 5%. Let's look at the 4 next. 4 could be 1, 3. If it's a sum. It could be 1, 4 as a product. But actually, it can't be 1, 3 because that would give us too many 1s and 2s and 3s in this column. We can get that another way though. This 1, 2 pair means this can't be 1, and regardless of whether we have a sum or product, one of these is 1. So this has to be our 1. It's 2, 2, and now we have a 2 pair. This is 1, and one of these has to be 1, so this is 1. Now neither of these can be 2, so this is our 2, 3, 2. We have 3, 5 here. These are 5 and 6. 1 needs to go here and here. That's all of our 1s. And now this 6 can't be 1 times 6 or 1 plus 5. So the remaining options are 2 times 3 as a product, would have to go this way, or 2 plus 4, but we've already got the 4 in the box. So this is 2, 3. This is 5 or 6, but we have a 5 here. The 6 gives us 4 and 6 here, 6 here. These are 4, 5. These are 2 and 3. Alright. Here we need a sum or product of 9. We actually can't do a product of 9 in a 6 by 6. We would need 3 times 3. And the only other option for 2 whole numbers is 1 times 9, but we don't have 9 available. So this has to be a sum, and it can't be 4, 5, so it must be 3, 6. We know the order. This is 5, 3, 5, 4, 5, 4. And now to finish off, we got 3 and 6, and 5. And that's how you solve sum or product. Alright, this is the first of our normal size Sudoku. It should be the only normal size Sudoku. But Bill's is also a 9 by 9. This is a Creasing Sudoku. We have normal Sudoku rules, 1 to 9 in each row, column, and 3 by 3 box. Additionally, we have these lines, and how are they creasing? They aren't folded. What creasing is referring to in this context is that they are increasing or decreasing, depending on how you want to look at it, from one direction or the other. So effectively, these are thermometers. We just don't know which end the bulb's on. So this could be a thermometer with bulb here, increasing, or it could be a thermometer with bulb here, increasing this direction. I don't know which. The bulb is not in the middle of the line. It's on one end. So we'll start with this long 9 cell. Either it's 1, 2, 3, 4, 5, 6, 7, 8, 9, or it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are the only possibilities. So we're going to have 1 and 9 on the ends. We're going to have 2 and 8. Have 3 and 7. We're going to have 4 and 6. And finally, we're going to have 5 in the middle, whichever way around this goes. Now, the next key step is probably the hardest thing to spot. You'll kind of stumble across it eventually, pencil marking, but it's in this column. And you'll notice we have 1, 2, 3, 5, and 7. But we also have 4 and 6 in this box. So these 2 cells can only be 8 and 9. And now we need 6 and 4 in that order. And that's going to tell us a couple things. This has to be decreasing from here. It's smaller here. The 4 here, in theory, we could have a 4 cell with 4 as the biggest digit, but it would be 1, 2, 4. 3 can't go. So this has to increase. And the only thing bigger than 4 that we can put in this box is 5. Can't put 9 because we don't have 10 and 11. The only thing bigger than 5, because of the 6, 8 here, is 7. And we have a 7, 9 here. So that resolves that line totally. The 7 is important because it looks up here. We have this 3, and now we know the order. It's 1, 2, 3, 4, 5, 6, 7. Alright. These are from 1 to 7, but because we're decreasing from here, this can't be 1 or 2, because these would be too small. So this is 7. This cell can't be 6, can't be 4, can't be 3. It's either 2 or 5, but it also can't be 2 because it would need a 1 here. So 1 already in the row. And then this is 2 or 3 because there's a 4 or 4. Okay, we need 1, 2, 3, and 6 here. This can't be 3 or 6. So now we have 1, 2 pair. So in the row, we have all of our low digits. We need 7, 8, 9, and we already have 7 and 9 here. So this is 8, this is 9, 8, this is 7. These are from 4, 5, and 9. 9, 5 that we pull out. Alright, let's look at this line next. First thing I'm going to note is we have 3 looking down and across. So 3 is in one of these cells. Can it be here? We need 3, 2, 1, but there's a 2. So 3 cannot be here. This is, and this can't be 2, so this is 2. And now what can this be? It can't be 5, so it's 4 or 6. It also can't be 7. 6 is going to go in one of these cells. Don't know which yet. We'll get back to that. Let's look across here since we have 5 digits. We need 1, 2, 3, and 9. We have 1, 2, and 9 here, so this is 3. We can't have 9 in these cells, so this is our 9. 1, 2. And now we know we're increasing from here. The biggest this can be, though, is 7. I'm going to stick a 7 here. Actually, we have a 1, 2 here, so we have 2. But 7 is our biggest digit. So this needs to be at most 6. And now what can this be? It can't be 4. It can't be 1 or 2. So in order to be less than 6, it needs to be 5. So this is at least 3 now. But this can't be 4 or 5. So in fact, it has to be 6. And this sort of thing is common in thermo puzzles. This is a variant of thermo. Sometimes you just have to go through the possibilities and pencil marks and things. Sometimes there are easier ways to see it, or different ways to see it, without doing so much pencil marking. But I am not afraid of doing it. We still need a 4 in this column. 4 there. These options are 3 and 6. Okay, the 6 here now rules 6 out of this cell, so this is our 6. 8 is not here, so this is 8. These are from 2, 4, and 5. Across here, we need a 7. We've got 2 7s here. Don't think we can solve these yet. This is not 4 though, and this is not 2. We still need 7 and 8 in this box, and they're solved. This 7. This then is going to be 2 or 6. Can't be 5, so this is the only place for 5. We still need a 9 in this column, and there's a 9 here, so that's the only place for 9. 4, 2, 5, 4. These are, this can only be 1, 2, so we have 1, 2 pair, and these are 6 and 8 in this order. These are 5 and 9 in order there. These are 1, 2, and 3. Okay, we place 4 and 5 here, so this is 9, 4, 5. We need a 1 in the column. Here we need a 4 and a 6. 4 there. The 6 gives us 3 and 6. 2 and 1 and 3. 1 and 2. 2 here. This is not 6 now. This sees 2 and 3 in the row, so this has 1 and 2. 6 and 1. 2 and 1. 3 to finish the row, 8 to finish that row, 2 here, and 9. And that's the solution to Creasing Sudoku. Alright, I'm going to have to be a little careful on this one. Sudoku Pad has some issues with pencil marks. If you type something and then undo, it has a tendency to erase all of the pencil marks. I don't know why that's the case, but anyway, we'll be careful. I have a second copy of it open. So this is Natural Anthem. This is a pencil mark Sudoku, and so we have normal rules 1 to 9 inch row, column, and box. Additionally, we have pencil marks in some of the cells, and they just tell us what the possible candidates are for that cell. So this cell can only contain 1 or 9. This puzzle is not gas, and it was intended to demonstrate a particular classic, or pencil mark in this case, Sudoku technique called a firework. And this is something that was developed by Shye. As far as I know, her puzzles were the first that featured this technique. And it's not something that is easy to spot unless you know you're looking for it. And even if you know it's in the puzzle, it's not always immediately obvious where to look. Bill has given us some hints. So what we're going to focus on is these cells, because they have a bunch of low digits in them. There's 1 through 5 in these cells, 1 through 6 in these cells. So the question to ask is, where do 7, 8, and 9 go in this row and in this column? So in this row, 7, 8, and 9 are in these 4 cells. In this column, 7, 8, and 9 are in these cells. Now, how are we going to get 7, 8, and 9 in blue and in orange? Well, we can put one of them in these corner cells. We'll put a 7 here and an 8. But we're going to have to leave at least one of them out of the corner cells. Maybe 2. If these were both 8, we would need both the 7 and 9 still in the row. Now, why is that a problem? Well, let's say we have 2 of them here. Let's say they're 7 and 8. Where does 9 go? In row 1, 9 would have to go in the blue cells here. And in column 1, 9 would have to go in the orange cells here. But the only way to do that, because they're in the same box, is to put the 9 in the overlapping cell. So what we've concluded is that whatever is not in these 2 cells, of 7, 8, and 9, must go in this cell. So that tells us 2 things. One, we have to have these 3 cells be different digits. So we can't have 2 of these corner cells, because now we would need a 7 and a 9. The second thing is we have pencil marks in this cell, and it can't be 8 or 9, so it has to be 7. And these are going to be 8 in some. We can do the same thing at the bottom now that we have these. So in these 5 cells, we have only high digits, 4 to 9. We don't have 1, 2, or 3. So where do 1, 2, and 3 go in the bottom row and in the rightmost column? Well, they can go here, and they can go here. And we have exactly the same pattern. We have 2 cells outside of this box that can contain 1, 2, and 3. At least one of them has to be left out. So in order to satisfy the row and the column, the third one has to go in the corner. And so this is a 3 because it can be 1 or 2 by the pencil marks. Now, we still have another, say this is a 2, we still have another 2 over here. And this would be a 1. We still have a 1 down. So we're going to end up with 5 of them total in these 7 cells. We don't need 6 because the corner cell is covering both the row and the column. So that's another way of thinking about it. We need at least 5 total from those digits. We can fit 2 here, and we can fit at most 3 in the box. So we have to have 2 here. We have to have 1 here that covers both. Okay. From here, we can start to do some regular Sudoku. And this column helps us out quite a lot, because this is not just low digits. This is 1 through 5. There's not even a 6. So, if these are 1 through 5, these must be 6, 8, 9, forming a triple. And 6 is not here, so 6 is in one of these cells. So that immediately gives us a 5. But also, it tells us that 6 is not in these cells. The only place for 6 now in row 1 is 7, 8, 4, and 5. And we'll keep going here. I do want to show what my bypass was, because it's related to what we just did. So the reason I solved this so fast is I've been working on some killer Sudoku nerd snipes, and one of the properties of those is that there's a separation between the low and high digits. So I've been constantly looking out for situations like this where we have a bunch of low digits, we have a bunch of digits. So what I noticed is this is 1 through 5. So these are 6, 7, 8, 9. And this is not 8 or 9. But these are from 6, 7, 8. Those orange to match. And now what I saw, which is definitely not gas, and I should have recognized that it wasn't gas, is where do we put 6, 7, 8, 9 in this row? Well, we can put one here. We have to put one. We can put one here. We can put one here if this is a 6. What we can't do is put 2 here, because that would give us 5 digits from 6, 7, 8, 9 in the box. So one of them is here, and the other 3 are here. And that means this is a 6. That means this is a 7. So this is 7, 7. So effectively what I did was a firework on 6, 7, 8, 9 with an extra cell. So instead of just these cells, I included this cell. And here, this cell. And it works the same way. We have an extra space for one more digit, but we still need 7 in the corner. We still need these to be the other. So, hopefully you find that interesting. If not, we'll get back to the puzzle. So we have an 8 here now, so this gives us a 9, and that immediately gives us an 8 down here. We could get that anyway by looking at this 9. 9 can't go in these cells now. 6 can't go in these cells now. 8 is in one of these cells. So 8. But we also get it from firework. That 8 gives us 7, and 6, and 5, and 4. Solving all of that. The fact that 8 is up here means this is a 2. The 4 here resolves all of this. 5, 8, 4. This is not 1, 3, 4, or 2. Alright, these are from 1, 3, 4, and 8. These are not 8. That means the only place for 5 now is here. And so this is not 5, 6, 7, 8, or 9, it is 4. This is not 4. That already was 4. This is not 4. We actually have a 1, 3, 8 triple here. These are from 1, 2, 3, and that 2 means this is our 2. Now we have a 1, 3 carrier, so this is our 4. Now where does 4 go in this row? It goes here. Where does 2 go? It goes here. The 6 here resolves 8 and 9. We still need a 7. I don't do that yet. We need 5, 8, 6, and 9. We have 5 and 8 here, so this is 6, 9, 6, 5 here. These are 1, 2, 6, and that's not 1. These are 1, 2, 9, and that's not 2. We do have 1, 2, 3 triple here. What do we need in this box? We need a 4 somewhere. 1, 2. I know there's something simple in this. I've solved it. This is 1. So now we have a 2, 6 pair here. This is not 2. This is 2. We have 1, 2 here. This is 3. This is 1 here. This is 1 here. And a 9. Okay, this is 6 and 9, 6. These are 3 and 7. The one here also gives us 8. 3, 8. These are 5, 6, 7, and so this is also 5, 6. Let's see, 7 and 9. This is 7 and pair. This is a 2, 9 pair. So 2, 9. 2 looks over here. 6, 2, 6, 5. 1, 3, and 6. But that has to be the 6. 1 here. The 8 here gives us 3, 3. We still need a 5 in this box. 2 5s. This is not 8. This is not 4. Any of those. We need a 3 in one of these cells. We need 7 right here, so this is the only place for 7, 7. These are 1 and 4. These are 5, 6, and 8. We've got 5, 8 there. We've got another 5 here. These are 1, 4, 7. These are all those. These are 2, 5, and 9. Alright, this is the only place for 8 in a row now. I don't know how long that's been sitting. This is 3, 1, 3, 1 and 9. This is 2 and 7. 2 there. It's 9, 7, 9 and 2. And finish. We need a 6 and a 9. And that's the solution. 2 different ways of looking at it. And I hope the explanation helped. There are longer explanations out there. I will try and find an example for you. Just if you're curious about this and applications to other puzzles. But it's a neat technique. It looks really cool when you pull it off. Alright, this last puzzle is one of mine, and it is called Little Zipper. This is a zipper lines puzzle. It's an 8x8. So we have normal Sudoku rules for 8x8. 1 to 8 in each row column, and 2x4 region. And we have zipper lines. So before I even explain zipper lines, I'm going to mark some cells. So these cells are the center of the zipper line that they were on. And what the rule tells us is that on the line, the central digit is the sum of digits that are an equal distance away from the center. So these two cells are 1 cell away from the center. They sum to whatever this is. These 2 cells are 2 cells away from the center. They also sum to whatever this is. So on. So these cells are all on this line, and they sum with another digit to this. So this has to be the biggest digit in the box. It is bigger than all the cells on its own. So this is 8. This is bigger than all the cells in this box, except for this one. And it can't be 8. So in fact, this has to be 8, and this is 7. And this is a totally symmetric puzzle. It's one of the things that you can do with constraints like this in 8x8 or 6x6 that you can't do in a 9x9 because they're even dimensions. So in an 8x8,
we can have a puzzle where if we rotate it 180 degrees, we get exactly the same thing. You can't have that in a 9x9. So, if you tried that in a 9x9, tried a puzzle with totally symmetric zipper lines, you would have at least two solutions. You would have to provide some additional information, or make it asymmetric. But this is something you can get away with in even dimension puzzles. Anyway, let's go back to these 8s, and let's think about these cells. These pairs sum to 8. They're in the same box. So, none of them are 4, because 4 plus 4 is 8. And we can't have two 4s in the same box. So the only place 4 can go is here, which is fine because it's paired with this cell, which is not in the box. So these are same thing here. This is 4. And now we can do something kind of neat. We could have done this with the 7s, but we do kind of need the 4 place there. And you can go either direction. I did it with 4s when I was testing this. It's cool anyway. Where does 4 go in this box? It doesn't go here, so it must go here. Now, what does that mean? If there's a 4 here, and whatever is up here sums with whatever is down here to equal 7, you have to have a 3 down here. If this is 4, this has to be 3. Well, neither of these is 4 actually. So this is 4. And same. This is the only place. But now we can keep going. Where does 3 go in this box? 3 goes up here. We can't rule 3 out of any of these cells, but what we can do is say, what does 3 need over here to sum to 8? We need a 5. Well, 5 is not in these cells, so it's in one of these cells. What do we need to sum with 5 to get 7? We need a 2. Well, now 2 is not in any of these cells, so 2 is up here. And we need a 6 to go with the 2 to make 8. And now 6 is not here, so it's here. In fact, we have a 5-6 pair here. We have a 1-2 pair here. And we're going to end up with 1, 3, and 5, 6, 7. The 7 already had to be done. So that's something neat. That you just have these pointing digits feeding back and forth and wind up with triples or pairs. We get the same thing then. These are 1, 2, 3. These are 5, 6, 7. 5, 6. And these are 1, 2. Alright, 7 is not here or here. Let's look at 8 again. 8 in this box can't go on the line, so this is 8. Same here. And now in this box, the only place for 8 is here and here. Again, it can't go on a line because it would have to sum with something that is at least 1 to make something that is at most 8. So, what can this be? This circle is bigger than all of these cells. 8, it's a 7. And now these are not 7. So we get a 7 here and a 7 here. That pairs with a 1 here and a 1 here. Alright, where next? 4 we can do some more with. We only have 2 4s left. And they go here and here. We need to sum to 7, so these are our 3s. We still need another 7, and they have to go here and here. They pair with 1 on the ends, and those 1s are going to disintegrate 1, 2. 2 goes with 5, 6. Okay. 6, 1, 6, 5, 6. The 2 here goes with 3, 2. 6, 5. And another neat thing here, we get 1, 1, 2, 3, 4, 5, 6, 7. I just think that's it. Alright, we need 3 and 6 here. So 6 and 3. The 6 needs a 1, which needs a 5. These are 2 and 5 now, in that order. And we can repeat all of that here, because again, this is totally symmetric. This is 5 here. Now to finish, we need 2 and 6. That's how you solve a little zipper. So that's something I might not have posted as gas normally, but because it's a special pack, and as we tend to include slightly harder puzzles sometimes in packs, I figured why not. So I hope you enjoyed those, and let us know how you did. Let us know if you would like to see solves of pencil puzzles. I don't know if those will appear on our channel, or if the Gap team will do walkthroughs of them. I don't know. We'll see. But bye for now. I had to record this twice, and so it is now late. I still need to edit. So, until next time.